Welcome, and thank you for listening to a session on how to protect users, apps, and data on Windows from a high-threat world. My name is ROHIT, and I'm joined today by Abhijat Singh and Braden. Here's our agenda. First, we will look at the current landscape of regulations that impact our industry, focusing on key compliance requirements and how they shape our approach to privacy and security. Next, we'll cover protecting users' privacy with app identity. Here, I'll explain how leveraging app identity can help safeguard user data and ensure privacy by design, aligning with both regulatory expectations and user trust. Then, Abhijat will cover the topic of administrator protection. This section will address the risks associated with administrative privileges and outline strategies and tools for minimizing those risks, keeping our systems and users secure. Finally, we'll explore protecting applications and data with VBS Enclaves SDK. Adam will introduce the VBS Enclaves SDK, explaining how it works and discuss how this technology can be used to protect sensitive applications and data from advanced threats. We'll wrap up with a few call to action items and outline some concrete steps you can take to enhance your application's privacy and security posture moving forward. Now, let me start by talking about global privacy and security regulations. This is really the foundation for everything we do in privacy, security, and compliance today. Every region, North America, Europe, Asia Pacific, Latin America, and even emerging markets are moving quickly to strengthen privacy and security laws. In the US alone, we will have 16 state privacy laws in force by the end of this year, which means even more complexity for anyone working across state lines. Europe continues to set the gold standard, not just with GDPR, but also with new digital and cyber resiliency laws, plus the world's first comprehensive AI Act. Asia-Pacific countries are rapidly updating their privacy frameworks, and Latin America is catching up too, developing new laws to match international standards. Even emerging markets are putting new data protection laws in place. And it's just not about data privacy and security anymore. AI regulation is now a top priority worldwide, with new rules rolling out fast to address new risks and challenges. I want to again emphasize that these global regulations shape how we build, secure, and manage technology. They drive our priorities, and they are changing the way we all work. So understanding this landscape is essential for everything else we'll cover today. Now, I want to talk about guidelines for app controls and transparency that we want app developers to consider. Let me bring these to life with a quick story. Imagine a user whose name is Sarah. Sarah relies on apps running on Windows every day to manage her finances, connect with friends, and to track her health. For Sarah, trust is everything. She needs to know that her data is protected, her choices matter, and that she's always in control. That's why these guidelines are so important. First, Sarah's data must be protected and her choices respected. She needs to feel confident that her sensitive information is safe and that she can decide what happens with it. Second, any in-app privacy controls should be intuitive and unbiased. If Sarah cannot easily find or understand her app privacy settings, she may make choices that she doesn't intend to, causing her to lose trust in the app. Third, Sarah should be empowered to make and change decisions about her privacy and security at any time. Her needs might change, but she should always have the flexibility. Fourth, privacy choices and notifications must be comprehensive. Sarah should never be left guessing. She deserves clear, complete information about her options and any changes that impact her. Finally, she should be proactively notified about changes to her privacy or security. Surprises erode trust, but timely and transparent updates build it. These are not just best practices. They are what real users like Sarah depend on every day. App developers should use Windows inbuilt capabilities where available to offer these options to your customers and add or update app functionality to enhance privacy and security features. And to help you implement some of these guidelines, you will hear from Adam later in this session, where Adam will walk us through some of the platform features we offer to protect user data. Now, let's look at why app identity is so important for customers' privacy and control. On the left side of this slide, you can see applications that have declared their identity. These apps are known to Windows and can be managed individually using their app identity. This means customers have granular controls. Windows can gate access to sensitive resources such as camera, microphone, and location for each app separately. For these, Windows cannot attribute or bind granular controls to individual processes. Therefore, there is no durable way to set permissions for individual apps. Instead, there's just a single master switch that controls access for all apps with no identity. This is a real risk. If one of these anonymous apps misbehaves or is malicious, customers cannot block that app without also blocking every other well-behaving app. This is why our modernization efforts begins with a focus on app identity. It is a foundation for giving customers real control over their privacy and security, so they can decide exactly which apps get access to their data and device resources and which don't. Without app identity, customers lose that control and are exposed to greater risk. Looking ahead, Windows will be changing the default setting for the master desktop toggle privacy switch from on to off. This change will first be seen in the camera, microphone, and location privacy settings pages. This means, by default, apps with no identity will not have access to these sensitive resources unless the customers explicitly change the setting. App developers should be aware that this change is coming. While the rollout date is still to be determined, we will provide plenty of public notice before these defaults go into effect. Now, let me give you a brief walkthrough of the user experience before and after an app has an identity and describe at a high level the steps you'll need to take to give your app an identity. Here, we have a demo app that uses the camera, and as you can see, the app is listed under the desktop toggle master switch. Now, we will turn off the master switch and launch the app. As you see here, the access to the camera stream is denied and the app fails to initialize the webcam. In the interest of time, I'm not going to walk you through a live Visual Studio demo showing how you can get an app identity, but at a high level, there are 4 steps to build and register an identity package. You will need to create a package manifest for the identity package, build and sign the identity package, add identity metadata to your desktop application manifest, and finally, register the identity package in your installer. Use our V6 extension to help you generate a package identity for your app. The linked documentation will walk you through this process in detail. Here, we have associated an identity with our test application. And now, when we relaunch the test app, you will see that Windows has generated a system prompt. If the user grants access to the app, it will now show up with a granular control in the camera settings privacy page. To wrap up, I want to highlight that proactive compliance isn't just about avoiding fines. It's now a real business advantage and a necessity. Regulations are getting stricter and customers expect privacy and security by default. To stay ahead, start every project with privacy and security as core requirements, not afterthoughts. Review and update your development practices to comply with new global regulations. Use Microsoft's compliance and security toolkits, and build trust by making user data protection a visible priority. Also, test your Win32 apps with the desktop toggles for camera, microphone, and location set to off, so you know how your app behaves when privacy controls are enforced. Update your apps if necessary. Take full advantage of Windows privacy features to protect your users' data and build trust. And finally, be ready for new AI and emerging regulations. The rules are evolving fast, so making privacy and security a priority now will set you up for success. With that, I'll invite Abhijat to come talk to us about administrator protection. Thank you.
Thank you, Rohit. Now, let's talk about a new security feature in Windows called Administrator Protection, which makes admin users secure and helps reduce malware. By default, most users on Windows run with full admin access. This means apps and services can also easily get system access and access to critical services. This increases the risks of malware attacks, where even an accidental click can lead to data lost, secrets being stolen, or even your machine can get flattened. UAC or user account control can help, but it is only an authorization control and can be bypassed. Windows is introducing a new admin security feature that allows access to the PC's critical resources only when needed and certainly not by default. This makes it harder for attackers to abuse admin privileges and deliver malware or malicious code to your PC. With this feature, we have built profile-separated admin and user tokens to provide users a greater protection by default. Yet, Windows remains flexible for admin users to self-elevate to admins if they want, when they want. In addition, we have completely removed silent elevations from Windows so that malware cannot bypass the user and abuse their admin privileges. With admin protection enabled, users will be prompted to authorize every elevation request, preferably by Windows Hello-based authentication, which will create a just-in-time admin token that will be used by the app and destroyed after use. Let us now see a quick demo showing the simplicity and convenience of Hello-based elevation with security of profile-separated admin and user tokens.
This is the device not enabled with admin protection. When you try to run Task Manager, it simply runs. It is in fact running elevated with admin privileges, but due to silent elevations, you do not notice it. Similarly, in Windows settings, you can easily change some settings with silent elevation happening in background. This is not good because malware can also change these settings silently without users' knowledge and can compromise the security of the device. Another thing to note is that on a device without admin protection, both non-elevated session and elevated session share the same user profile, as you can see from the command prompts. So a malware running as user, without admin permissions, can easily modify Windows registry to insert bad content that gets executed when an app is run elevated to infect the device. Now, let's see how this changes with admin protection. On this device, admin protection is enabled by going to Windows security settings and simply turning the toggle on, followed by a reboot. When you try to run Task Manager, it prompts now ask the user to explicitly authorize the use of admin privileges. Similarly, changing system settings require users to authenticate and authorize the operation securely using their hello face, which a malware just cannot do. Let's now see how profile separation increases the security here. As you can see here, with admin protection enabled, non-elevated and elevated command prompt do not share user profile. A malware running as user without admin permissions can still modify Windows registry to insert bad content. As you can see, bad content was inserted in HKCU, which malware has write access to. However, when the app was run elevated, malware was not able to infect the device. With admin protection enabled, a profile-separated, system-generated admin account is used to prevent malware from infecting the system.
To summarize what you just saw in the demo, firstly, admin protection limits silent elevation and hence disallows any bypass of UAC to abuse admin privileges. Secondly, it integrates seamlessly with Windows Hello, enhancing both security and convenience for users to authorize use of admin privileges. Thirdly, and the most important one, how profile separation prevents attacks where malware injecting bad stuff into user's profile can compromise the device when an app is run elevated. Admin protection feature is currently available in Windows Insider's Canary channel, and as you just saw in the demo, it can be easily enabled from Windows security settings. This feature will soon be enabled by default in Windows, and hence we encourage you to test your apps with it enabled and reach out to us with your feedback. I will now hand it over to Adam, who will talk about platform security features to protect customer data.
Thank you, Abhijat. Now we'll discuss the third part of our session to explore what we are doing in the platform to help application developers protect their secrets and sensitive data. Let's take a closer look at what VBS enclaves are and the capabilities they provide. But first, let's quickly review customer needs for secure computing on the client. We are seeing more concern over attacks targeting application secrets, such as your sessions, tokens, passwords, or encryption keys. Apps need more tools to protect their secrets and keep their secrets a secret. Additionally, we are seeing a growing need for secure computation and data processing of confidential data, and to accomplish this in such a manner that it cannot be exposed to other users. VBS enclaves are a technology that can help protect the most sensitive parts of your application, protect your app secrets, and provide developers a way to confidentially process data. So what are VBS enclaves? VBS enclaves are a trusted execution environment inside the address space of the host app. It uses Windows Hyper-V hypervisor to create an isolated privileged virtual environment known as Virtual Trust Level 1. And that becomes the root of trust for the OS. The traditional Windows environment is called VTL0. VTL1 is further split into an isolated user mode and the secure kernel. This technology is what Windows uses to host many of its security features inside VTL1. The hypervisor maintains access and privileges for these virtual trust levels and guarantees that VTL1 is isolated from VTL0. Think of VBS enclaves as a way to further harden your applications. VTL1 is a privileged space, and we only allow code that's been signed by Azure Trusted Signing Service to run inside it. Let's take a quick look at the key capabilities that VBS enclaves provide. Code integrity is there to ensure a high bar for code being allowed to run within an enclave. Attestation enables the enclave to attest to the state of the host system, the enclave itself, DLLs loaded in the enclave, and boot information such as whether or not a kernel debugger is attached. This can be remotely attested to with Microsoft Azure Attestation and leveraged by a service to determine whether a device is trusted in order to connect to resources. And lastly, a limited API surface area helps with security because the attack surface is smaller. This ensures that we can maintain the integrity of VTL1. Secondly, it requires that you, the developer, think about how best to design your application and minimize the amount of code in VTL1. There are a couple key benefits and considerations for app developers. First, data in use is protected within the enclave because the VTL1 memory is not accessible, not to malicious users, debuggers, or admins. Only data that's been released from the enclave to the host app is accessible. Second, data at rest is protected and not accessible outside the enclave. The encryption keys are sealed by the enclave. Sealing is the process of protecting and encrypting data within a trusted execution environment. It allows sensitive data to be securely bound to the enclave, ensuring its confidentiality and integrity. One of the considerations for an enclave is that it is just a DLL and can be loaded by any process. Thus, app developers need to think carefully about their scenario and what they are trying to protect. So with that overview, let's take a quick look at how security threats would apply to an enclave. Here we have a user session, a host app, and another running process. In the Windows security model today, Typically, any app would try to read the sensitive data. However, because the enclave has encrypted the data and sealed its encryption keys, neither process can directly decrypt the data. The host app must go through the enclave, which unseals the keys and decrypts the data within the enclave. Now, a malicious process would have to target the host app or load the enclave DLL itself by reverse engineering its calling pattern. So that's the security landscape today. But you might ask, is there anything else we can do to protect the data? Well, there is a new approach we are looking into, which was introduced by Recall. Essentially, we require proof of human presence before releasing the encryption keys. This means the enclave can define policies as to how often to prompt for physical user consent and to authorize access to that sensitive data. This is a feature we are looking to productize as part of our future roadmap. The other technique for an enclave is to throttle or limit the amount of data it releases. Recall uses this technique to minimize how much data can be extracted at any point in time. The enclave would also need to define policies for this behavior. So we've learned about enclaves, their benefits, and some limitations. What I'd like to introduce you to next is the VBS Enclaves SDK. Its goal is to make enclaves more approachable and easier to use. It includes libraries and headers for common functionality and new code-gen API tooling that makes building your API projection layer for your enclave interface. Let's take a closer look. Today, the programming environment for enclaves is very basic. The supported platform APIs are limited, and the developer experience is all manual. You essentially have a single function, call enclave, with a p-void to pass in all data, all pointers, call stacks, and any data structures. In addition, all parameter validation and memory safety must be tediously coded by hand by the developer, which can lead to a lot of errors. With the VBS Enclaves SDK, you now have additional library support for enclave creation and management, thread pools, cryptography helpers, logging, and much more. In addition, we built a parser for the enclave definition language, or EDL. Our implementation is based on the EDL schema from Intel and OpenEnclave. Much like IDL, or Interface Definition Language, this code generation tooling handles all the heavy lifting for marshaling your data across that host-to-enclave boundary, performing parameter validation and memory safety checks. It provides you, the developer, a much more approachable programming model and allows you to focus on business logic for the enclave. Okay, enough talk. Let's see it in action.
Okay, here we have the VBS Enclaves tooling repo. It is the repo for the SDK, which consists of 2 NuGet packages, a code generator, and the API helpers. Here you'll find the source, the docs, and samples. Instead of starting with a simple Hello World app, I want to show you the sample app in the repo. It is a great tutorial for using the SDK and highlights the code gen capabilities. It demonstrates encrypting a blob of text and thread pool management. Here I have it loaded in Visual Studio. Let me show it working first, and then take a look at the code. To do that, I need to set up remote debugging. Here I've got the remote debugging property set up and the IP connection to the VM. Now, let's take a closer look at the VM. Requirements to debug an enclave in a VM include: a TPM must be present. You set that up in the Hyper-V settings for the VM. Turn on test signing at boot. You do this with BCD edit. And lastly, you must turn on memory integrity by going to the Windows Security app, choosing Device Security, and then Core Isolation, and flip the toggle for memory integrity and reboot. Okay, let me F5 the sample app. I've already built and deployed the sample, so it should load quickly. Here you see a menu of 3 options the sample supports: encrypting text, managing threads, and encrypting multiple blobs of text across multiple threads. For this demo, we'll choose the first option and just encrypt the simple statement, "Hello from build 2025. In the sample flow, you see that it asks the enclave to create a sealed key, then passed that sealed key back to the enclave along with the text to encrypt it. The sample saved the encrypted text to a file called encrypted. Now we can load that file into Notepad and see that it is encrypted text. Now we can go back into Visual Studio and rerun the sample to decrypt the file. This time we press 1 and then Option 2 to perform the decryption. Here you see the enclave unseals the key and uses it to decrypt the text. Okay, I've walked through just the first example. Now let's go back and take a closer look at the code and highlight the tooling and SDK capabilities. To start building your enclave, first you need to reference the NuGet packages in both the host and enclave projects. You can see I've added them in packages.config. Now we begin to define our interface for the enclave. It all starts with an EDL file, which is very similar to a regular IDL file. As I mentioned earlier, the schema is based on OpenEnclave's definition of enclave definition language, which you can find at openenclave.io. This file shows all interfaces defined here. Here is the create key flow that asks the enclave to create a sealed encryption key and return it, and the encryption flow, which takes the sealed key and a string as input and returns the encrypted text. Now this EDL file must be referenced by both projects, so let's switch to VS Code, which I have here. Here you see the reference to the EDL file and a couple properties to tell the code generator what namespace to use and the class name of the enclave. We also need to specify which side of the interface it is generating, the host or the enclave. Now, let's switch to the enclave, which has a few additional properties to set. You see the reference to the EDL file, and note that we are now generating the enclave side of the interface. Now we must set linker options that are specific to building the enclave. And lastly, we must ensure that the enclave DLL is signed. I created a post-build event using a self-signed test certificate I created for debugging purposes. Now it's ready to build. Let's switch back to Visual Studio and see what it generates. The tooling will generate new headers for the host and enclave, stubs.h for the host and implementation.h for the enclave. Let's take a closer look at the host and stubs.h. Here you can see the interfaces for defining the enclave, managing callbacks, and for encrypting and decrypting a blob of data. Here we get a look at all the marshalling code required to pass the parameters between host and enclave. Notice we use flat buffers for our marshalling layer. The code gen does all this work for you, which makes programming the enclave much more straightforward. Now, let's look at the enclave side and implementation.h. Here we see the API declarations and the ABI interfaces, along with the marshalling layer built on top of flat buffers. Let's take a look at how your application can use these headers. Starting with the host side, main.cpp has the code for the encryption demo you just saw. Note the reference to stubs.h. And here we see the first usage of the SDK libraries. All SDK namespace begins with Veil for VBS Enclave implementation libraries, which are helper libraries and functions. For the host, you are mostly interested in the enclave management and logger functions. Let's jump to the encryption function. Here we see the Veil libraries for the logging routine, as well as properties and methods to help simplify enclave creation and registering the callbacks. And a little further below, we get into the actual encryption function. Now we see the code for calling into the enclave. First, we get a sealed encryption key from the enclave and save the sealed key to disk. Then call the enclave passing in the key and the user input to encrypt. The function will return the encrypted bytes back to us, and the result is saved to disk. On the enclave side, it's very similar. We need to open the file, 𝗦𝗽𝗲𝗸𝗀𝗀𝗻𝗀𝒀𝒐𝒫. And here you'll see the reference to the implementation header. A little further below, you see the main function of the enclave. In this sample, the function is overloaded for both encrypt and decrypt functionality, so it's doing a bit of extra work and has more parameters as a result. The enclave also references and uses the 𝗲𝗀 libraries. There are many more for memory management, cryptography, logging, and enclave information. Now we get into the core of the function where we unseal the enclave, create a new encryption key, and use that to encrypt the input text. And with that, we are done with the demo and the sample app.
And so that's a quick look at what it can do today with a lap around the SDK and sample app. I showed you how to set up your project to build, to define your interface, and use the SDK for enclave management and performing cryptographic operations. I also covered the requirements for your debugging session. With the time we had today, I've only been able to hit the high-level points. For more detailed information on setting up your dev environment for enclaves, please refer to the development guide. And be sure to go to our repo and get the latest NuGet packages, explore them, and provide us feedback. Though enclaves target a very specific scenario, I did want to note that we are working with a few internal and external partners on this SDK. As for the roadmap, please comment on the repo for what you'd like to see. Here's a peek at some things under consideration. Okay, we've come to the end and you've seen 3 topics on how Windows can protect users, admins, apps, and data. Please explore these options today and provide us your feedback. Thank you.